Hey guys, it's Miss Latham, and today I want to talk about angle side angle and angle side triangle congruence. These are the notes for the lesson that I sent you. Let's look up at the top. It's talking about angle side angle. It says if two angles in the included side of one triangle are congruent to two angles in an included side of another triangle, then the triangles are congruent. So let's look at the triangles that they gave us. It says if, and we're talking about these two angles, angle A is congruent to angle D, and then this side is congruent to this side, so AB is congruent to DE, and then we have these two angles, angle B is congruent to angle E, then these two triangles are congruent, so triangle ABC is congruent to triangle DEF. Alright, and then this is just explaining that included means the side that is between the two angles. So you can see that this side is actually a part of these two angles. Alright, let's do the first proof. So they give us the SQ bisects angle RQT and angle RST, so that's given. Alright, because this is bisecting, that means that this angle is congruent to this angle. So angle RQS is congruent to angle TQS, and that's by the definition of an angle bisector. And then we also know that RSQ would be congruent to TSQ for that very same reason. Alright, well, like we talked about before, this side or this segment is a part of both these triangles and it is congruent to itself, and that is the reflexive property. So therefore, these two triangles are congruent. We have an angle and an angle with the side that is included, so that would be the angle side angle theorem. All right, let's look at the next one. All right, we have that JK is parallel to LM, so JK, LM. I'm going to draw my little arrows to show that those are parallel. It also shows us that JL is parallel to KM. So I'm going to give each one of these two arrows. And that is given. So they say angle JKL, here's JKL, is congruent to angle MKL. So JKL is congruent to angle, MLK. And if I look at these two parallel lines right here, this would be my transversal, this is my parallel lines, and these are alternate interior angles. Alright, then we have JLK is congruent to MKL, so this angle is congruent to this angle. And this time we can look at these two parallel lines, and this is the transversal, and those are also alternate interior angles. Alright, and then this segment is a part of both of these triangles. It is congruent to itself, and that's the reflexive property again. So I know that these two triangles are congruent, and how do I know that? And again, we have angle side angle. All right, let's look at a few more. All right, this time they're not helping us out any. We've got to do it all on our own. So I'm going to look up top at the given first. It says angle BAC is congruent to angle DEC. So angle BAC congruent to angle DEC, and that is given. So let's go ahead and mark that. BAC is congruent to DEC. All right, they also tell us that C is the midpoint of AE, and that is given. Well, if C is the midpoint of AE, then that means this is the middle, so I know that this segment is congruent to this segment. So I know that AC is congruent to CE, and I know that because of the definition of midpoint. All right, so we have an angle and a side, and we also have these two angles are congruent. How do we know that angle BCA is congruent to angle DCE? They are vertical angles. All right, so we got an angle, we got a side, we got an angle. So I can say that triangle ABC, which is what I'm proving here, is congruent to triangle EDC by the angle side angle theorem. All right, let's look at angle side. All right, for angle side, it says if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the angles are congruent. Basically what it's saying is if you got two angles that are congruent and a side across from one of those two angles is also congruent, then you've got angle side. So if angle A is congruent to angle D and angle B is congruent to angle E, and BC is congruent to EF, then I know that triangle ABC is congruent to triangle DEF because of the angle side theorem. All right, let's try one of these proofs. It says that YZ bisects angle WYX. So YZ bisects angle WYX. Well, I'm going to go ahead and handle this. Since this is bisecting, I know that this angle is congruent to this angle. So I'm going to say that angle WYZ is congruent to angle XYZ, and that is because of the definition of an angle bisector. And I need to write given up here. All right, and then the other thing they've given me is that YWZ, angle YWZ, is congruent to angle YXZ. So let's see here. YWZ is congruent to angle YXZ. All right, and that is given. So what else do we know? We know that they share YZ. We know that YZ is congruent to itself. And that's the reflexive property. So what can we say? We can say that triangle WYZ is congruent to triangle XYZ, and that is by the angle side. Okay, let's do just a few more of these. Whoa, there we go. Okay, up at the top. let's use orange. We have that angle ABC is congruent to angle CED. So ABC and then CED, and that is given. All right, let's go ahead and get our other given in here. We have that AB is parallel to CE. So AB, I'm gonna draw a little happy arrow, is parallel to CE. Boom. And that is given. Oh, we got another given. And they tell us that C is the midpoint. I'm going to abbreviate that. Of AD. So here's C. It's the middle of the segment. So I know that AC has to be congruent to CD. So let's say that next. AC is congruent to CD. And that is the definition of a midpoint. All right, we got an angle, we got a side. I need another angle. Which angles can we say are congruent that'll help us out? How about angle BAC is congruent to angle ECD? Let me write it down. Angle BAC is congruent to angle ECD. All right, now how do we know that these two angles are congruent? We got these parallel lines. What kind of special angles are those with these parallel lines? It's not alternate interior this time. Does anybody know? They are corresponding angles. All right, so we got angle, we got side. I guess I should say angle, angle, side. So I can say triangle ABC is congruent to triangle CED, and that is by the angle, angle, side theorem. All right, two more. All right. I think I'm gonna go with red. All right, first they tell us that PR bisects angle QRS. So let's see here. PR bisects QRS. All right, that's given. And let's go ahead and say if this is bisecting, that this angle is the same as this angle. So I'm going to say angle QRP is congruent to angle SRP. And that's the definition of an angle bisector. All right, they also tell us that angle PSR is congruent to angle PQR. So PSR, this one, and PQR, this one are congruent. So that is given. We have an angle and an angle. All we need is a side. We got this handy dandy side. So I know that PR is congruent to itself. And we have used this a bunch. It's the reflexive property. So we are good to go. Angle, angle, side, angle, angle, side. So I can say triangle PSR is congruent to triangle PQR by the angle, angle, side theorem. All right, one and done here. Okay. Lime green. All right, LG is parallel to JM. So LG is parallel to JM. Draw my happy little arrows. That is given. All right, we have H is the midpoint of LM. So here is LM, here's H in the middle. This is the middle. I know that this distance is the same as this, and these two segments are congruent. So I know LH is congruent to HM, and that is the definition of a midpoint. All right, so if we have these two parallel lines, and here is my transversal, then I know that this angle is congruent to this angle. So I can say, and I'm only going to use one letter because it's the only angle hanging out over there. So I'm going to say angle G is congruent to angle J. And what kind of angles are those in relation to these two parallel lines? Those would be alternate interior angles. All right, so we got an angle and a side. We need another set of angles, so I can use the fact that these two angles are congruent. So since there's two angles here, I have to use more than one letter. So I'm going to say angle GHL is congruent to angle JHM. And that is because of the, anybody? Vertical angles theorem. All right, so we got an angle and angle side, an angle and angle on the side. So I can now say that triangle LGH is congruent to triangle MJH by the angle side theorem. All right, that's it. You guys have a great day.